Alright guys, let's discuss on exercise 5.6 on finding inverse using Jacobian function. Okay, let's look at question number 1 and question number 2. We can see that the question is similar. Right, and they want us to find, both of the questions want us to find the same thing. So where's the difference that we have in the question? They have the same z function. They have the same query. They want us to find partial z over partial u and partial z over partial v. However, the information provided on the x and y and u is not the same. For the first one, they give the z function, they give the function, the x function, and they give the y function. So the x function in u and v terms, and y function is in u and v terms. So, and lastly, they want us to find the partial z over partial u and partial z over partial v. So we have function x, and we have variable u and v in the x and y terms. So for the first question, right, it is solvable using chain rule, or the topic of change of variable video that we have discussed before, because there is no inverse that we need to use here. We don't need no need for us to conduct any inverse, so we don't need to use Jacobian to solve for the first question. Let's look at the second one, right, with the same function, same questions, but with a different functions of u and v here. So for this, for the first question, they give us the function of x in terms of u and v, y in terms of u and v. As for the second one, they give us a function u in terms of x and y, and function v in terms of x and y. But still, they want us to find, to give them the same answer, which is partial z over partial u and partial z over partial v. We know that if we just conduct chain rule, we the only possible answer that we can obtain is partial z in terms of x and y, right, because that is the variable inside the terms. So for this case, in order for us to find dz over du and dz over dv, we are going to need to inverse these functions. So instead of u in terms of x and y, v in terms of x and y, we are going to inverse it. Okay, so let's look at the question. So the main objective is to find partial z over partial u and partial z over partial v. So as usual, I just write down all of the information, and then the question, partial z over partial u. So how to find partial z over partial u in the situation that we have another two variables inside it? Okay, so this is how, based on the chain rule, this is how we should calculate it. So to obtain partial z over partial u, it will be partial z over partial x times partial x over partial u, plus with partial z over partial y times with partial y over partial u. So now let's see, can we look for each of this information, right, to later come up with partial z over partial u? So can we look for partial? We can look for partial z over partial x by using the first function here. So we get 3x squared plus y. We can also look for partial z over partial y using this first function, which will give us x plus 6y, right? But for the final two components here, partial x over partial u and partial y over partial u, notice that the function that we have is u in terms of x and y, v in terms of x and y. So if we were to find it directly, we can only able to get the function of maybe partial u over partial x. So not actually partial x over partial u. The same goes for this one, partial u over partial y, not y over u. So it is the other way around. Therefore, to get partial x over partial u rather than partial u over partial x, we'll need to conduct an inverse function, which will later involve a Jacobian function. So this is the partial that we want to look at, partial x over partial u, based on the formula of inverse that we have looked in our previous video. It should be the other way around, so we put u and x with the complement of it. So instead of u is a v, instead of x is a y. So this will be the numerator, and the denominator is j. Alright, so let's see on how can I get this value. Okay, the Jacobian function for our equation, right? This equation, we have u in terms of x and y, v in terms of x and y. So let's find the determinant of it by arranging it like this, or maybe you can choose to put partial u vertically. It doesn't matter, as I said before. So find the determinant. Alright, so find the partials for each of these components and substitute it to find the determinant, and there you have it, 30x minus 16y. That is the value of Jacobian function. And so we have j that will act as a denominator in our inverse process. Okay, so partial v over partial y. Look back at the function. Partial v over partial y will give us 5. So I put it here. And then the other one, so basically this answer is equal to partial x over partial u. That can be substituted here. Now let's look for partial y over partial u. That will be going on the same process. Partial y over partial u, the complement yet inverse numerator will be v over x. Okay, however, don't forget to put negative, right? You have a negative for partial v over partial x here. So the partial, we know that the Jacobian is this 30x minus 16y. How about partial v over partial x? So look back at the function. Partial v over partial x will be equal to 2. So I put it here. So this is the whole derivative for partial y over partial u. So we can substitute it back in this. So all in all, we have this is partial z over partial u functions. So I just calculate it and simplify it to give me this answer. Right? So this is the answer for the first one, which is partial z over partial u. Now the second question, partial z over partial v. We are going to do the same thing. So the chain rule for partial z over partial v will be partial z over partial x times with partial x over partial v, z over y, y over v. And of course, the same problem will be we are going to have the same problem. So we have this information, right? They are the same information as above. How about this one? Partial x over v, partial y over v. We don't have the information just yet, because if you know, the one that we have is v in terms of x and y. So to get x over v, the same process, which is inverse, and we already have the information of Jacobian, which is 30x minus 16y that we have used before in finding inverse. We are going to use the same information, but for now, alright, then we are going to find out for partial x over partial v, and the numerator for it will be partial u over partial y, which is inverse and complement for this one. And for this one we have negative, right? For partial u over partial y, it will have a negative. So let's find out partial u over partial y. So partial u over partial y if you look back, partial u over partial y will give us 8y, right? So we have negative 8y here, yeah, negative, just put negative beside 8y. Okay, let's talk about the simplification later. Let's move on to the next one. We already have partial x over partial v, right, in this form. And the next one will be partial z over partial y. Sorry, partial y over partial v, right? The same process. Y over v, the inverse complement of it is partial u over partial x, but now without negative. So partial u over partial x is equal to 6x. Right, we have 6x there. So partial u over partial x, yeah, 6x. So this is, when you substitute, this is what you get for partial v over partial y over partial v. Now, for the simplification, right, if you look at this, I did conduct the simplification for the two, okay, for these two. Okay, to conduct a simplification, right, the tips is make sure that when you simplify, it did not change the denominator. So if you simplify for partial x over partial v, right, you're able to get 15x minus 8y as the last simplified denominator, and you simplify this one and you get the same kind of denominator. Then you can proceed with the simplification. If not, just leave it as in its original form, right? Because if you simplify and it actually changed the numerator, and this two is not the same, it will later makes your calculation complex. So that is a tips. Okay, so I just substitute all of the information I have and simplify it to this final answer. So that is how I embed Jacobian function in the chain rule that we have used in our previous videos, right? So I use Jacobian function to inverse, right? To inverse the function. So in the case where you have this kind of function where it is actually quite tally with the equation, so where you have x in terms of u and v, there is tally with the equation where you want to find z in terms of u, then for this one there is no need for you to use Jacobian. Alright, I hope you understand when to use Jacobian function. Just compare between these two and you will understand when to use Jacobian. Right, so that is for Jacobian function. Thank you.